All right, so here is question 24. Just kind of looking ahead, looks like it is a direct and inverse variation problems. Just a little quick review on what direct and inverse means. Basically, direct variation is as x goes up, y goes up as well. So it goes, direction is just a straight line. Or as x goes down, y also goes down. It's a straight line going down. Inverse variation, on the other hand, is the opposite. So like basically as one goes up, the other one goes down. As one goes, or if one goes down, the other one goes up. I don't know what I'm trying to draw here, but the graph. Okay, so let's see what we have here. So it says that an experiment is conducted on a container of gas that is kept at a constant temperature. When the pressure of the gas is at 30, the volume goes up to 120. And when the pressure of the gas is at 40, the volume goes up to 90. Let P represent the gas, and then the pressure, and then V represent the volume. Okay, so let's just kind of maybe make a table. So it says that V is volume. So we're just going to write it as a coordinate. And then P is pressure. And then it looks like I have two coordinates, right? The first one is at 30. When it's 30, it is at, volume is at 120. Okay. And then when the pressure is at 40, looks like the volume is at 90. So you can clearly see as the volume went up, the pressure went down. So we can say that this is a inverse variation. So from here, we just have to find that constant. So you know that the constant for inverse variation, you will find it by multiplying x and y, or in this case, v and p. Okay, for direct variation is you divide y and x. But yeah, so for this one, to find that constant, it is going to be 30 times 120. I need decimals for this. 30 times 120 is 3,600. So the K constant is 3,600. And then the equation would be for inverse variation, it's going to be, I'm just going to take this off. We're not even looking at direct. We're only looking at inverse variation. So the equation for inverse variation is y equals k over x. Okay. In this case, it would be p equals, because y is p, k I said was 3,600 over x is v. Okay. Now we could write it like this, or we can say PV or VP, like multiply these two together and get 3,600. I know it's got a little complicated on this, but I mean, it is what it is, right? So maybe I'll show a different way to do it. But anyway, first of all, it's inversely variation, and then VP is 3,600. So volume times pressure I got was 3,600. So even if I do like 40 times the 90 is also like 3,600 since it's a constant. Okay. I mean, yeah, that's how you would do this problem. You just have to analyze how the numbers are working. Okay. The next one, a relation in the table is shown. Alright, so I know I've been telling this in class, the moment you see a table, just put it in decimals, okay? And then we'll go from there. So I'll go ahead and take this, put this in decimals. 1, 4, 8, 8, and then 20. And just type it in. I think we did this problem in class. Okay, I'm just going to zoom out. So it looks inverse to me, right? Because it matches that inverse graph. It's not a straight line, but it has that curve right there. So I know it's going to be inverse. So I can go ahead and take off the direct variation, and then now I just need to match the graph. So I think I'm gonna make my life a little easier and just match the graphs here. Y equals x plus 1.25. That didn't work, so it looks like it should be 10. And then I'll explain the equation to you, but 10 equals xy. That worked right there, so it's definitely D. Anyway, the reason I picked inverse was because once I plotted it, I can see the shape of the graph, so it shows inverse. And then x times y is always going to be the constant 10. So like if I did here, like for example, x times y, x times y, and it's like, what is xy? Well, I'm just going to take off this little one here. I don't really need it. X times y you see is constantly 10. So like 1 times 10, 4 times 2.5, and then so on. Keeps getting 10. All right, next question. A couple more here. Directions. Plot each point on the grid. The coordinates must be integers. Okay. The point shown on is an element of a direct variation. So you know that the direct variation, I can go ahead and use the straight edge to kind of show you what the graph should look like. It should go through 0, 0, and it has a slope of 1. So it's the one line that's kind of going right through the middle. Let me kind of fix it. Doesn't have to be perfect because I'm not answering using the straight edge. It's just for me to find it. Actually, my bad. It doesn't. It has to go through 0, 0, but it has to go through this point. So let me kind of change it right there. Okay. So basically, you're asked to pick 2 other points that are on this direct variation right there. Okay. So the point shown is an element of direct variation. Plot 2 other points. So you know for sure one point that I'm going to plot is at 0, 0 right there. I need to move the straight edge out. Sorry. So you know this is going to be one point, and then if you look at the slope, so it's up 3 over 2, just find the slope up 3 over 2. That should work right there. And I'm just going to measure it out with the straight edge as well. So that works out. Okay. It's not perfect because I'm not perfect. But anyway, it's right there. Okay. So again, whenever it's asking for direct variation, only for direct, it's going to have the 0, 0, and then just count the slope. So up 3 over 2. So up 3 over 2 as well. And that's how you answer that question. 27. Using the quadratic curve of best fit, write an equation. Okay. So right here, I'm going to go ahead and just put in the table. So I'm going to press that, and then I'm going to say it is just plug in the x values and -8 right there, -7, -6, -5, 3, 5, and 7, and then plug in the other values. I'll pause the video here. Alright, I went ahead and put in my values right there, and then it's asking me what is the equation for curve of best fit. Now you have the option, which is the easiest option, is to go ahead and graph all this and see which one best matches this graph. I guess we can go ahead and start with that, and then from there we'll just check using the regression formula. But let's see, at least I can eliminate a few. That looks okay. It's going through, it's following that shape, so I'll go ahead and leave that one. Some of them will be obvious no's. Maybe this one will have like an obvious no. I think that's an obvious no, but I'll leave it because again, it has that general shape. So like they both look pretty good to me, so I just don't know which one is best. I think I do have to use the regression. That one also looks good. And then 1.7x squared. What am I typing? All right, let's see which one looks the best. That one's okay. That one's also okay. I mean, that one looks pretty good right there, right? I would definitely go with that one. Anyway, I'll have that, but I also want to just type out the regression for you guys so you have it, The quadratic regression formula, as we've practiced in class, is y1 regressed against ax1 squared plus bx1 plus c. And you can go ahead and confirm your variables. So a is 1.7, b is 2.9, and c is negative 5.2. So all right, last question. This table, okay, I'm just going to stop here, and I know that I'm going to probably have to go ahead and plug this in. So let me go ahead and plug that in first before I even read the rest of the question, or you can read it while I'm doing it. But anyway, table, and then 6, 10, 12, 15, 20, 27, and then plug these numbers in. Okay, so for the numbers here, there are numbers, so don't put the comma. Okay, it's not gonna, Desmos is not going to know what to do with that comma, so don't put the comma even though it's there on that table. Oops. One more. Make sure also when you're doing the table that the x and y's match. So yeah, there you go. It looks good. All right, now let me go ahead and read the question. The table shows the number of months used and the approximate distances driven in miles for 6 buses in a school district. Okay, so bus A, data, bus B, and then so on. Notice I did not put any of this in my table. I just need the x and y here. All right, using the line of best fit, okay, line of best fit, which has a different formula for these data. So let me go ahead and go put that line of best fit. So that's y1 regressed against ax1 plus b, and I have my a and b right there. Which value is the best prediction for, let me take this off real quick, best prediction for the distance driven in miles. So the distance, we're looking for this here in 40 months. So basically what we're trying to do here is we are trying to find what is it for 40. So since I have a and b here, I can say what is y when a times 40 plus b is, plus b is 91,426. So that's that. Okay, so that's the practice I have for the TestNav. So again, TestNav is the application that you're going to use to take your SOL next week. Showed you where to find Desmos, some of the tools, and how to answer the questions that are a little different from multiple choice questions. All right, thanks guys.